right, last section of chapter 3. So we're going to look at inverse trig functions, and we're also going to look at taking the derivatives of inverse trig functions. So to understand this, I want to start out just by really fast reviewing the graphs of sine, cosine, and tangent. So I'm going to start with the sine. So if you look at the graph of sine of x, remember it starts at 0. At 2 pi, you go through one cycle, so you're back there. At pi, it crosses. At pi over 2, you hit 1. 3 pi over 2, you hit -1. I know it's been a little bit since we've done this, but this is, kind of missed my point there. That's what 1/2 of it looks like. Let's look at the other half. You know, the B points there, there, and there. So there's your graph of sine. And it just keeps going, right? Now, if we look at that function, the question is it a one-to-one function? And the answer is no, right? If I try my horizontal line test, I guess it's going to touch multiple times. What that means is the sine function does not have a inverse function unless I restrict the domain. So we're going to look at the sine function. Instead of looking at the entire function, we're going to go from negative pi over 2 right there to positive pi over 2, just that part there. So I'm going to put that down. I'm going to restrict the domain to be negative pi over 2 to positive pi over 2. Now if I look at that, just that part, that, you know, the part I outlined in blue there, that is a one-to-one function, right? It passes the horizontal line test. That means it also has an inverse. The range, by the way, the answers I get back out, right, they're always between -1 and 1. So when I go to look at the inverse sine function, y equals the inverse sine of x, what happens, right, is the x and the y's just switch places. So the domain of this one is going to be from -1 to 1. And the range, my output, will just be between negative pi over 2 and positive pi over 2. And we're going to graph it in a second and see what it looks like. But just kind of think about that. That's the domain and range of my inverse sine function. I'm just taking the domain up here and the range up here and switching them. Okay, let's do the same thing for the cosine function. So cosine starts at its peak at 1. At pi, it's at its minimum. At 2 pi, it's back up to the top. It crosses halfway between there. So it looks something like that. And we could keep going this way also. Those are all my points. Okay. So there's the cosine function. So similar to the sine function, it does not have an inverse unless I limit the domain. But on this one, we're not going to limit the domain from negative pi over 2 to pi over 2 because it wouldn't be 1-to-1. But if I go from 0, from when x is 0 to when x is pi, on that stretch right there that I just outlined in red, it is a 1-to-1 function. So what I'm going to do is I'm going to restrict the domain to go from 0 to pi. And I'm going to restrict the range to go from -1 to 1. Well, when I go to find the inverse in, so when I do the inverse cosine function, I'm going to switch those around. So the domain of it would be from -1 to 1. And the range, my answer I get back out is going to be between 0 and pi. Okay, let's look at the last one. The last one we're going to do is tangent. We're only going to do inverse functions for the first three, for sine, cosine, and tangent. So remember tangent, it has a vertical asymptote at negative pi over 2, positive pi over 2. If I kept going over here at 3 pi over 2, there'd be another one. It crosses at 0, 0. There's a point at negative pi over 4, -1, pi over 4, 1. Looks something like this. Then it just keeps repeating itself over here, right? Looks something like this. Same thing over here. So if you look at it, it's not 1-to-1 either. So what we do is same thing as up above, is I'm going to restrict it to go from negative pi over 2 to positive pi over 2. We're just going to look at that part right there. So the domain would go from negative pi over 2 to pi over 2. If I do that, now it's a 1-to-1 function. Now it passes the horizontal line test. The range, doesn't want to write over there, I'm going to come down here. The range, right, it goes from -infinity to infinity, right? Goes down forever, goes up forever. So if I take the inverse tangent function, we're going to switch those two around. So long story short, when we get all done with that, look at this big box. This was in your book right here, right? They do not have inverses unless we restrict the domain. And what that means is when I switch those around, when I find the inverse sine, I have a restriction on what answer I can get back out. By the way, side note, the inverse sine is the same thing as the arc sine. That's supposed to be inverse sine. So inverse sine of x, same as the arc sine of x. Same thing with the inverse cosine. So arc sine, arc cosine, arc tangent are just mean the inverse. That's all they mean. So if you look at it, if I'm doing the inverse sine, I can only plug numbers in between -1 and 1, and my answers I get back out will always be between -π/2 and π/2. Same thing with the cosine. I can only plug in numbers between -1 and 1. My answers I get back out will be between 0 and pi. For tangent, I can plug anything I want in, right? Domain is -infinity to infinity, but my answer I get back out is between -π/2 and π/2. Well, let's look at those graphs, and then we'll actually go through and evaluate some of these. The very last thing we'll do is find the derivatives. So if I want to graph y equals arc sine of x, which is the same thing as the sine of x, what I'm going to do right below is just really quick. Remember our sine function? We said we went from -π/2 to π/2. Those were our points, and it looks like that. That's the sine function with the restrictions on it, just looking from π/2, -π/2 to π/2. So let's use that to graph our graph up here. So I have a point at -1, -π/2, -1. So if I switch those around, it'd be -1, -π/2. There's a point at 0, 0. That's still going to be 0, 0. And there's a point at π/2, 1. So that'd be 1 π/2. Okay, think of that line y equals x. It has to reflect across that. So this one's going to look like this, and that one's going to look like that. That is what the inverse sine function or arc sine function looks like. Let's do the same thing with the cosine function. So with the cosine function, we went from 0 to pi. So there's 0, we'll say this is pi, and it started at 1, and at pi it was down at -1, and it crossed halfway in between. So that's what the arc cosine or inverse cosine look like. Okay. So if I want to do the inverse, take these points and switch them. So this one has a point at 0, 1. So this one would have the point at 1, 0. But there's a point at π/2, 0. If I switch those around, it'd be 0 π/2. This one has a point at π1, -1. So go -1 pi. Okay, then we have to reflect it. So if you look at this part is here, that's this part right here, reflected across. This part right there is that part reflected across. So that is what arc cosine or inverse cosine looks like. Okay, y equals arc tangent. Remember with tangent, we limited it. We only went from -π/2 to +π/2 across to 0 at pi force 1. There's a point, -pi force, there's vertical asymptotes. So the way it looks something like this. So when I do the inverse tangent, remember the x's and the y's switch. So if this one has a vertical asymptote at -π/2 and pi/2, this one has a horizontal asymptote at -π/2 and +π/2. This one has a point pi force -1, so I go -1, pi force, point at 0, 0, and a point at 1 pi force. So sorry, pi force 1, so I switch those around, be 1 pi force. It looks like that. So there's your three graphs. We're not going to do a lot with the graphs. This is more just to provide us with background information and help us with that. What you will have to do is you have to be able to evaluate arc sine, arc cosine, and arc tangent, and then we'll also have to find the derivatives. So that's what we're going to spend most of our time on. Really quick, just as a visual though. So when you think of the arc sine, arc cosine, arc tangent, normally with sine, cosine, tangent, you plug in the angle and get the ratio back out. With arc sine, arc cosine, and arc tangent, you plug in the ratio and you get the angle back out. So the answer you get back out, the range of values you get back out for sine, for arc sine, it has to be between -π/2 and pi/2. For arc tangent, same thing, but it does not include -π/2 and pi/2. Your answers for the arc cosine, the answers you get back out, have to be between 0 and pi. So let's look at this. I think this example 2 is a really good way of thinking about this. So sine of -π/6, let's do that problem. So -π/6 is right there. That's that angle right there. It's 30 degrees. So if I make my reference triangle, if that's 30, this side has to be 1. Just do remember our special right triangles we have. This side would be 2, this side would be the square root of 3. This side should actually be a -1, right, because it's going down. sine of negative pi over 6 is opposite over hypotenuse, or y over r. It'd be a negative 1/2. Let's do the sine of 7 pi over 6. 7 pi over 6 is 1 and 1/6 pi. So that's 1/6 pi. That means it's 30 degrees. Okay, this side is still negative 1. This side is 2. This side is a negative square root of 3. Sine is opposite over hypotenuse. So it's still a negative 1/2. So same answer, right? Two angles, I got the same answer. Hey, let's look at sine of 11 pi over 6. So that would be 1 and 5/6 pi. That actually puts us right over here. That means it's actually the same as this triangle over here. It's that angle and that angle we say are coterminal. They end in the same spot. So this is negative 1, 2, square root of 3. Sine is opposite over hypotenuse. So it's a negative 1/2. So we've already done that before, right? But what I want to point out is you can plug different angles into sine and get the same answer back out. And that's important because when we go to do arc sine, we're going to plug in the ratio and get the angles back out. But you can only get one angle back out. Well, if I plug in a negative 1/2 and find the angles that go with that, there's at least 3 different angles. There's actually a lot more than that, right? We could find as many as we wanted. So we have to limit, go back up here, we have to limit. So when I go to do arc sine, I only look between negative pi over 2 and pi over 2. So look at those 3 answers. 11 pi over 6 is not between negative pi over 2 and pi over 2. Either is 7 pi over 6. Negative pi over 6 is, right? Negative pi over 6 is right here. It's between negative pi over 2 and positive pi over 2. So the answer is negative pi over 6. So that's the trickiest part of evaluating these inverse trig functions, is you have to make sure that your answer that you get back out, the angle, that it falls within the range of answers that are allowed for each one. And you have to know for arc sine, it's negative pi over 2 to pi over 2. For arc tangent, it's the same, just doesn't include negative pi over 2 and pi over 2. And for arc cosine, it's between 0 and pi. Let's do a couple more problems, just where we're evaluating here. So it says, what is the arc tangent of 1? So what that really means is, what angle do I plug into tangent and get 1 back out? So think of your reference triangle. In fact, we have 2 different reference triangles, right? We have a 30, 60, 90. 30, 60, 90. And it's, let's see, 1, 2, square root of 3. And we have our 45, 45, 90. So that would be 45, 90. And it is 1, 1, square root of 2. Remember, tangent is opposite over adjacent. So it would be 1 over that. It's a 45 degree angle that gives us a tangent, the value of 1. Now the second thing is, our answer has to be between negative pi over 2 and pi over 2. It has to be either here or here. It has to be on this side of the circle. So since it's a positive 1, I want it to be up here. So it's 45 degrees, 1, 1, square root of 2. Tangent is opposite over adjacent, 1 over 1. So the answer is what this angle is, 45 degrees. We're going to do it in radians though. 45 degrees is pi force. Now just be aware, there's actually another spot over here. You could draw a triangle over here, if my board will let me, and this is negative 1 and negative 1. That tangent of that angle would still be negative 1 over negative 1, which is 1. And that's 5 pi over 4. But 5 pi over 4 doesn't fall within the range of values. So just make sure that your angle has to fit in your range of values. Okay, let's do arc cosine of a negative 1. This one's a little easier because when you're asking when does a cosine equal negative 1, that has to be on the x or the y axis. So cosine is the x coordinate. The x coordinate is negative 1 right over here, right? That is negative 1, 0. So what's that angle? Pi. Does pi fall within our range of values? Look right there. Yes. Cosine goes from 0 to pi, and it includes pi. So there's my answer. Okay, the answer comes out to be pi. So I plugged in the ratio. I got my angle back out. Inverse sine of a negative square root of 3 over 2. So again, inverse sine, it's got to be this one or this one, right? Between negative pi over 2 and positive pi over 2. So when does it equal a negative square root of 3 over 2? Well, sine equals a negative down here. Up here, you'd have a positive y over the hypotenuse. So draw your reference triangle down here. The opposite side has to be this negative square root of 3. The hypotenuse has to be 2. That side would be 1. And what angle is that? Well, this is the long side, so it's the 60 degree angle. 60 degree angle is pi thirds, And because you're going down, that would be a negative pi thirds, is my answer. D is the easiest one of all. What is the arc sine of 2? Well, remember, you're saying when does a sine, for what angle does a sine equal 2? The sine never equals 2. The highest it gets is 1. The lowest it gets is negative 1. Remember back here, one more. You can only plug in numbers into the arc sine between negative 1 and 1. Same with the cosine. So the arc sine of 2 is not possible. Okay, can't do it. Hey, grab a calculator. Practice plugging these in. Just a couple things to know on your calculator. Number one is you have to make sure it's set to radians. And the second thing is where to find it. Right above the cosine, or right above the sine, there's an inverse sine button. So the calculator uses that inverse sine notation. That's the same thing. So grab your calculator, plug that in there. You can pause this and do it. This one would be, again, right above tangent. So, sorry, right above tangent, there's an inverse tangent button. That's the same as the arc tangent, same thing. So grab a calculator, you can pause this and plug that in there. Make sure you got the answers. They come out to be, the first one is like 0.304, the second one is like negative 1.190, is what you should end up with right there. Okay, so if you look at these three examples, the first one says, what is the sine of the arc sine of square root of 3 over 2? Hey, sine and arc sine are inverses of each other. They just cancel out. Man, that not writing well, but that's square root of 3 over 2. Tangent of the arc tangent, same thing. That's just 3. Arc cosine of the cosine, again, cancel out. Pi thirds, pretty easy. It all seems easy. Then we get to here. We got a problem. If you say this is 11 pi over 6, that is incorrect. And here's your reason why is when you take the arc sine of something, it doesn't matter what it is. When you take the arc sine of something, remember our answers have to be between negative pi over 2 and pi over 2. 11 pi over 6 is not. So on this one, we just have to work it out. So let's do that. Let's find the sine of 11 pi over 6. We actually just did this problem, but that's 1 and 5/6 all the way over to here. So this is my angle right here. That's pi over 6, which is 30. That means this side is 1 or negative 1. This side is the square root of 3, and this side is 2. The sine is opposite of our hypotenuse. So I end up with the arc sine of a negative 1 over 2. Okay, figure out what that is. Well, hey, I already have my triangle drawn, right? Negative 1 over 2 is right here. So it's a 30-degree angle. But the difference is I'm not going to go all the way around to find that. I'm just going to go down this way. So what is that angle if I go that direction? That is a negative pi over 6, and that's my answer. That fits between negative pi over 2 and pi over 2. So sometimes if your answer, right, 11 pi over 6, doesn't fit within your range of answers for arc sine or arc cosine or arc tangent, you just have to work it out. Just start with the inside, find out what it's equal to, and then do the outside afterwards. Let's solve this equation. I want to solve for x. I have the arc sine of x squared minus 3 equals pi over 2. I can't do anything with the x as long as it's inside of the arc sine. So I'm going to take the sine of both sides of my equation to get rid of the arc sine. So I'm going to go the sine of the arc sine of x squared minus 3 equals, right, I took the sine of the arc sine, equals the sine of pi over 2. So I took the sine of both sides. Over here, those just cancel out. X squared minus 3 equals, what is the sine of pi over 2? Well, pi over 2 is right here. The sine is your y coordinate. That point is 0, 1. So your y coordinate is 1. Okay, solve that. Add the 3 over. Take the square root. So your answer could be a positive 2 or a negative 2. Could be your two solutions. Okay, we're going to do these last two examples, and then we're going to actually get to the calculus stuff. So this first one says, given x equals the arc cosine of 2 over the square root of 5, find the tangent of x. A couple of things. First of all, what this really means is when does the cosine equal 2 over the square root of 5? Remember, cosine, arc cosine, has to be either here or here. Has to be in one of those two. And to get 2 is the adjacent side, square root of 5 is the hypotenuse. So to get a positive adjacent side, it's got to be going to the right. So my reference triangle has to be over here. And the adjacent would be 2, hypotenuse would be square root of 5. We need to figure out what that, and then I want to find, this is my angle x, right? I want to find the tangent of x. Tangent is opposite over adjacent. So I need to figure out what this side is over here. So use Pythagorean theorem, 2 squared plus, let's call that, just call that y. 2 squared plus y squared equals the square root of 5 squared. So we'd have 4 plus y squared equals 5, minus the 4 over, take the square root. So this side over here has to come out to be 1. Hey, once you got this done, this is easy now, right? Tangent of x, that's just opposite over adjacent. So the answer is a half. Okay, I'm going to warn you ahead of time, 8 is kind of weird. We're going to do it just this one time. It's going to help us discover the derivative rule for the arc sine. So don't stress to follow along with me. Hopefully it makes sense, but you're never going to have to recreate or do this. So it says y equals arc sine of x. I'm going to make it x over 1 just to make it into a ratio. We're going to do the same thing as we did over there. Arc sine means it has to be here or here. So I'm going to draw a triangle. So here's my triangle. X is the opposite side, 1 is the hypotenuse. And this is my angle right here, my angle y. I need to find the cosine of y, I need adjacent over hypotenuse. I need to figure out what this side is equal to right there. So I'm going to put just something down there. I'm going to put in like an a down there and use Pythagorean theorem. So I'm going to go a squared plus x squared equals 1. I'm trying to figure out what a is. So I'm going to minus the x squared over. A squared equals 1 minus x squared. Take the square root of both sides. So a is equal to the square root of 1 minus x squared. So put that down here. So the question is, what is the cosine of y? Well, that's the adjacent side over the hypotenuse. So that is equal to the square root of 1 minus x squared over 1. So really just the square root of 1 minus x squared. Now that doesn't really probably too much for you. It doesn't make a lot of sense, or not sure how we'd ever use that. But the only thing we're going to use it for is we're going to go back and we're going to find the derivative of the arc sine, and we're going to use that fact that the cosine of y equals the square root of 1 minus x squared to help us find that derivative. Okay, so let me show you that. So the next example says, now we're getting to the actual calculus stuff. It says, what is the derivative of the arc sine? So what I'm going to do to find that, I'm going to set it up. I'm going to write it as being y equals arc sine of x. And I want to find y primed. I want to find what y primed equals. Well, the problem is I don't know how to take the derivative of arc sine. So I'm going to take this top equation and rewrite it. I'm going to take the sine of both sides. I'm going to take the sine of y equals the sine of the arc sine of x. I'm going to move this out of the way really quick. The reason why I did that is now I have the sine of y, and these two cancel out, sine and arc sine. So that just leaves me with sine of y equals x. I know how to take the sine of y, and I know how to take the sine of x. I didn't know how to take the arc. So in this form, I can take the derivative. We have to do implicit differentiation. So take the derivative of the sine of y. That would be the cosine of y times by the derivative of the inside. Derivative of y is y primed. And then take the derivative of x, which is 1. Remember, I'm trying to find y prime. So I'm just going to divide by the cosine of y. So I end up with this. Right? The derivative of arc sine of x is 1 over the cosine of y. Well, the problem with that is I don't want things in terms of y. I want things in terms of x. Hey, this is why we did that last problem. Go back and look at 8. We just said the cosine of y is equal to the square root of 1 minus x squared. So come back to here. I'm going to write that my final answer is 1 over this. I'm going to replace the cosine of y with 1 over 1 minus x squared. Try to replace the cosine of y with the square root of 1 minus x squared. Okay, this is your derivative, and that's where it comes from. Now, you're not going to have to recreate this. You're not going to have to find the derivative by hand like that. You're just going to add these to your note cards, to what you're memorizing, so that you can find these. So the derivative of arc sine is 1 over the square root of 1 minus x squared. That's what we just discovered, right? If you put a function of x in there, right? So u is a function of x. Then what happens is you end up with 1 over the square root of 1 minus the inside, which is u squared, times by the derivative of the inside. Well, when you times by u prime, the u prime just ends up on top of the fraction. So that's why the u prime's up there. Our cosine is exactly the same, only it's a negative. So if it's a function of u, same thing. It's exactly the same, but it's a negative. The arctangent is, there's no square root, it's just 1 over 1 plus x squared. Or if there's a function of u on the inside, it's u prime over 1 plus u squared. Again, u is just a function of x. So let's apply these rules. We'll do these last three examples here. So g of y equals arctangent of 2y minus 1. I'm going to find g prime of y. Let me come down here a little bit where my board's working better. We're going to find g prime of y. All right, so just look at your rule right there. The derivative of the inside goes on top. So the derivative of 2y minus 1 is 2. And then on the bottom, it's arctangent, so I go 1 plus whatever's on the inside, that's my u, 1 plus u squared. And we're done. There's my answer. Okay, let's try 11. So this one, the inside is the square root of x. That's the same as x to the 1/2, right? So let's apply our rules. We're going to go f prime of x is equal to, look at your rule, the derivative of the inside goes on top. So what is the derivative of x to the 1/2? 1/2 x to the negative 1/2. All over the square root of 1 minus, and then I take what's on the inside, the square root of x, and I square it. That's my answer. Now, this is a free response. I would just stop there. If it's a multiple choice, they're probably not going to leave it like that. They're going to simplify it. So let's look at a couple ways we could simplify it. If you have a half up on top, you can just write it as being this, 1 over 2. And I'm going to take this x to the negative 1/2 and move it to the bottom. It'd become x to the positive 1/2, or square root of x. And I still have this other square root down there. Square root of x squared is just x. So I moved this to the bottom. I moved the 2 to the bottom. I made this a square root. I simplified the inside of that. So that could be your answer. You could even go a little bit further and say that's 1 over 2. And you could, because they're both square roots, you can times them together. You could even times that extra if you wanted to. So all three of these are the same thing. You know, multiple choice, there's a good chance it'd be written that way. So just be, if it's free response, we don't have to simplify it, but we ought to be able to simplify it if necessary. So number 12, h of t equals the inverse cosine of the ln of t, right? Inverse cosine is the same as the arc cosine, same thing. So we're going to use our arc cosine rule. So we're going to say h prime of t is equal to, and I'm going to do the rule. So take the derivative of the inside. So derivative of ln of t is 1 over t, square root of 1 minus, sorry, because it's arc cosine, we have to add the negative. Square root of 1 minus the ln of t squared. Not a lot you can do to simplify that. You can move the t down to the bottom. So if you want to write it this way, negative 1 over t square root of ln of t. Sorry. Let me redo that. It's not the t that's squared, but it's the ln of t squared. So ln of t squared. Not a lot you can do there to simplify it besides that. Those are a little tricky, but once you get used to them, in the end, it's just a matter of knowing the formulas. So it's just adding more formulas to the list. Make sure with your note cards, as we go through and you get formulas, that you are adding those as we do that. So, all right. That's it. That's all I got for you. On the assignment, really the 1 through 15 is just reviewing how to evaluate and how to work with the three inverse trig functions. It's when you get to number 16, I believe, is where it starts actually working through the derivatives. So that's the actual calculus part. Good luck. Talk to you later.